Hello, ladies and gentlemen. Mr. Donahue here. Again, looking to go over some problems, looking at the 5.3, 5.4 problems for chemistry. Start with question number 8. So we're talking about enthalpy and enthalpies of reactions, talking about heat and how heat changes during these reactions. So for the first one, it says a blank delta H corresponds to a blank process. So things to remember, if we have a positive delta H, that means a gained heat, which would be endothermic, right? And if it lost heat, it would have a negative delta H and be exothermic. So we're looking for an option where those two are correct and matching with each other. And it's B. A negative delta H is exothermic, right? Not too bad. All right, looking at number 9. Which of the following statements is false? So you always got to be careful with these ones. Want to look for the one that's false. So it's kind of counterintuitive to be like, all right, well, A, internal energy is a state function. Well, that is true, so it is not the right answer. So intensive basically means it doesn't matter on how much stuff you have, it's always going to be the same. So an example would be like density, right? It doesn't matter how much gold you have, it'll have the same density regardless if you have an ounce of it or, you know, a Scrooge McDuck vault full of it. Density is still the same. Extensive is the opposite. Extensive depends on how much stuff there is. Things like mass. So mass would be extensive, right? That does depend on how much you have. Enthalpy is an intensive or is not an intensive property. So this is false, which makes it the correct choice. Right, the enthalpy change for reaction is equal in magnitude but opposite in sign. So the enthalpy changes for the reverse reaction. That is true. This is a true statement. Right? If you are looking for, you know, A becomes B and you have a delta H, well then if you do the opposite, B to A, it would be the negative of that delta H. It's the same magnitude, just the opposite sign. Right, choice D, the enthalpy change for a reaction depends on the state of the reactants and products. Absolutely. If we're using H2O in a reaction, whether it's liquid or versus if it's a gas, those, oh no, what happened? Those two things make a significant difference. Right, hopefully that fixes itself. All right, here we go. 10. The reaction 4Al plus 3O2 gives you 2 aluminum oxides with the delta H of that is blank, and therefore heat is blank by the reaction. Well, if it's got a negative delta H, we know that it's exothermic. So that gets rid of 2 of our choices. And what's it mean to be exothermic? It loses heat. Kind of a definition question. So we want exothermic and releases heat. 11, a blank delta H corresponds to a blank process. Again, positive delta H, it's endothermic. And if it's a negative delta H, it's got to be exo. So we look for which one is consistent with that. And it is choice C as in Charlie. All right, number 12. Another one where we're trying to match positive and negative with the endo and exo. All right, so it's just like the last one, but different. Delta H for an endothermic process is positive, while delta H for exothermic is negative. So choice E. Number 13. The value of the delta H naught. So you gotta look, that naught means standard conditions. All right, for the reaction below is given as 790, negative 790 kJ. The enthalpy change for the accompanying reaction of 0.95 grams of it. All right, well, see, you gotta remember the delta H naught. The units on that are usually kilojoules per mole. So we're talking about if we had 1 mole of that, that's how many kilojoules you would get. But we don't have 1 mole of that, we have 0.95 grams of it. So this is what we're gonna do. All right, we gotta convert grams to moles. So we do 0.95 grams times by the GFM of sulfur, which is 32.1 grams in 1 mole. All right, grams cancels out. And now we can times that by the negative 790 kilojoules in 1 mole of, oh man, I totally messed this up. 1 mole of, it's not 1 mole, right? Because we're looking at the equation here, and it's saying for every 2 moles. So 2 moles of sulfur gives us 790 kJ. So we'd set it up like this, and we end up with our final answer of C, Charlie. Right? So you got to look at the coefficients. So the delta H is per mole of reaction. So if this reaction were to go on, it would give you 790 kJ. So if you had 2 moles of sulfur, that's the max you can end up with. So you got to account for that. All right, let's take a look at 14. So the value of delta H and all for the reaction below is that number. Blank kilojoules of heat are released upon combustion of that. So it's, again, similar to the previous problem. So we're given grams. We don't like grams, so we got to get rid of this grams. We got 16.0 grams times, well, 1 mole of it is 72 plus 6, 78. I just did that math in my head, 78 grams. So now we got moles of that stuff. Now we want to figure out, well, what is the ratio? Well, I get that much kilojoules for every 2 moles of that stuff. So now these units are going to cancel out, and I should end up with my final answer of C, Charlie. Mr. Johnny, why isn't it negative? Because it's just talking about how much heat is released. So they just want the magnitude. They don't care about the sign. They know the heat's being given off. They want to know how much. 15. Hydrogen peroxide decomposes to water and oxygen at a constant pressure by the following reaction. Calculate the Q in this exothermic reaction when 4 grams of it is decomposed. So it's, again, same but different problem. So they're giving us grams. We don't like grams, so we convert grams to moles, which you're going to do pretty much any time you're working with a balanced equation, because those coefficients are in terms of moles, not grams. It's 2 moles of H2O2. All right, so we got to go convert that. Well, 1 mole of it is how many grams? 34 grams, right? You look that up, find that number. That'll give you moles of H2O2. And now you go, all right, well, what's my ratio? I know I get 196 kilojoules given off for every 2 moles of H2O2. All right, so now you just do the maths. Do the maths and you get the answer of hopefully B, because that's what I just circled. All right, moving on. Number, what, am I doing the right problem? Yeah. Why are these numbered all weird? Oh no, I'm just looking at the wrong, I'm an idiot. Turn the page, Donnie. All right, 16, last one in this section. The following delta H knots for the reaction below is for negative 482 kJ. Calculate the heat released to the surroundings when 6 grams of CO reacts completely. So same but different. I don't like grams, so I convert grams to moles. 1 mole over the GFM of CO, right, which is 28. So that'll give me moles of CO. So now I want to look at my ratio. The delta H is negative 482 kJ, which is what was given to me. So I got divided by, well, how many moles is that reaction talking about with CO? 2. So what do we get? We do the maths, we get the final answer, should be C. Right? Check that in my head real quick. Yep, that seems right. Hope you found that helpful. Hope you become experts. Hope to see you again.